Hello guys, today we will see the Leetcode problem number 85, which is maximum rectangle. Let's see what the problem is want to tell us. Here is the given the rows by columns and binary matrix filled with the zeros and ones. Find the largest rectangle containing only ones. Return its area. Okay. Now here we only have to find out the largest rectangle which is only containing the ones only. Okay, the whole array, whole matrix we have given to us, and in that whole matrix only zeros and ones are present, but we have to figure out the rectangle which is having only ones. Okay, no zeros should be present in that rectangle. Let's see this example. Okay, let's see this example here in the whiteboard on blackboard. So here the largest rectangle which is having only ones, so we have to return its area. Area means length into breadth. Okay, so by observation we can see that this is 2 by 3. This 2 by 3 can contain area of the 6, so our answer should be 6. Now how we will get this? Okay, how we will get to know this, that this is the largest area. Okay, largest area is this. Okay, now let's see the constraints. Here the constraints are 200 only. Rows and columns can be 200, so that's why we can go up to the this 200 means 2 into 10 to the power 2. Okay, so now when we traverse from row and column, so row by column, so we have to multiply it with the 2, 10 to the power 2 again, so 4 into 10 to the power 2, so that's why we will get the 10 to the power 4. So our maximum time complexity should be the 4 into 10 to the power 4. Okay, so this when we traverse. Okay, now after that we can go up to the 10 to the power 8. Sorry, we can go up to the 10 to the power 8. Okay, but here we have 4 into 10 to the power 8, so we cannot go. Okay, this 4 into 10 to the power 8 will be equal to the n to the power 4. Okay, means n we can represent it with the row or column. Okay, row or column we can say. Now we can go up to the n to the power 3. Okay, so n cube we can go up to the n cube. Okay, so n cube we will have the n cube until 4 into 10 to the power 6. Okay, so the n cube time complexity can be passed here, or we can go till log n into n cube. Log n into n cube we can go up to this also. Okay, so this time complexities can be passed, only n to the power 4 cannot be passed. Okay, now how we will get to know that answer, that the maximum area of the rectangle will be 6 only. So how we will get to know the answer here? Let's see that how this answer we will get. Let's discuss this solution. Okay, now here we will traverse from left to right. Okay, in this row wise. Okay, now if you have watched my previous video, which is based on the maximum histogram. Okay, so this is similar to that only, that problem. This is similar to that problem only. Now here we will traverse from left to right. We will get to know that this is the block which is having the 1 by 1, means all the numbers, all the cells are with the 1. Okay, so this can be answer can be is equal to the 1. Okay, answer can be 1 here now. Okay, now after that we will traverse from this to this. Here 1 by 1 matrix having 1, so it can be also, answer can be also equal to 1. Okay, then we will traverse from this to this. Okay, firstly we will remove that. Okay, now we can go here and we can see that these two cells are having 1 and 1. Okay, both are having 1. Here we can conclude that here the matrix, here the rectangle we can get will be 2 by 1. Okay, 2 by 1, which is 2. So our answer can be updated to the 2. Okay, then after this our answer will be 2. Then we will go ahead in this line, and here we have got the 1 and 1. Okay, now again we have got the 1 and 1, so 2 by 1 matrix. Okay, after this again we have got the 1. So here what you can see that we, if there are present, if there are, okay, just for the sake of example, if here 1 is present, okay, if there is a 1 is present, here 0 is only present, but here it is 1 is present there. Okay, in place of 0, 1 is present there. Now what will happen to it? What can be happen to it? That this whole rectangle, okay, this whole rectangle can be treated as 5 by 1 matrix, and our answer will be updated to the 5. Okay, so in this way our answer will get updated. Okay, because this is also a valid rectangle, yes, which is having all the cells of as 1. So to get this, how we will get to know that this rectangle we can count in our answer? Okay, so we will get the prefix of this whole matrix, prefix. So how we will get the prefix for this whole matrix? So to get the prefix of this whole matrix, we will try to calculate the length, that height of that matrix. Okay, the maximum height of that ones. Okay, so here 1, the height of the number of ones is only 1. After that we have again 1, so we will add to it. Okay, we will add this to it. Okay, this will be added and this will be 2. Okay, the 2 is the longest height now, so that height should not be break, that none of the middle number should be the 0. Okay, after that this will be added to it and 3 is there. After that this will be added to it and 4 will be there. Okay, so in this way we will get the prefix of all of them. Okay, so prefix of all of them, here we will get 0, here we will get 0, and then we will get 1 here, then we will get 0. Okay, after getting 0 now, okay, now here it is 1, here it is 1 is there, but after that we should add it. But if and only if there is only 1, so then we will add it to it. Okay, then it will be changes to 2, but now here 0 is present, so that's why we will only write it as a 0. Okay, 0. So our continuous ones chain has broken now, so that's why we have initiated our prefix chain of the ones with 0 again. Okay, now let's say for the example, if here it is 0 is present. Okay, here 0 is present, so this 1 will not be there. Okay, or we can say that if there is a 2 only and here it is 0 is present. Okay, 0 is present, so this whole will be changed to 0, and 0 plus 1 will be 1. Okay, in this way. But now we have here 1 and here 3 and 4. Okay, now we will get again all prefixes. Okay, so there is a 1, there is a 1, then 2, then 3, then 0 again. Okay, here it is 1, here it is 1, then here 2 is given, 2 we will there, then prefix, then here is a 3, 0, 1, 2, and here 0. Okay, in this way all the prefixes we have mentioned. Now we will traverse from whole row, okay, to the row. We will traverse from whole row. Okay, in this row we have the maximum height as a 1, so in this way, to get this, okay, to find out the maximum rectangle for that particular row, okay, the particular row will be the base of that rectangle, and above them will be the rectangle height. Okay, so for every of them, if we are traversing for this row, so this will be the base. Okay, the rectangle cannot be present at the below, it only present at above of them, just like this whole rectangle. Okay, just like this whole rectangle. This can be a rectangle, this can be a rectangle. Okay, this can be a rectangle, also this can also be a rectangle, but below this cannot be present any of the rectangle. Okay, let's erase this all. Okay, now to get this, how we will find out that what is the size of that rectangle. Okay, so for this size, to find out the rectangle size, we will get to know that all the prefixes. Okay, we will write it down, all the prefixes sum was 1 0 1 0 1 0 and 0. Okay, so now here 1 is there, so the maximum length of that rectangle can be only 1 by 1. Okay, now let's see for the third row. Okay, let's see for the third row. It is a prefix. Let's write down the prefixes 3, 2 and 2. Now we have this prefix. Okay, now we have to figure out that what is the maximum size of that rectangle. Okay, maximum length into breadth of that rectangle. So for this we can use the code which was present on the previous video. Okay, previous video code we can use of that one. And now we will get to know that how many. Okay, now we have to apply here the different algorithm. Okay, to find out. Okay, so I will tell you that which problem you should solve before approaching this problem. Okay, so I will just tell you which problem you have to solve. Okay, I'm not getting it. Yes. Okay, maximum rectangle. So the similar problem, similar questions, largest rectangle in the histogram. Yes, this is the problem which you should solve first, and after that you will get to the approach of this problem. Okay, so this problem you have to solve first. Okay, after that you can use this code only to calculate the largest rectangle in that particular row. Okay, So you have to solve this question first. Okay, after solving this, okay, now I will be discussing that how to solve this question. Okay, so this will be similar to this only, so you will get to know that how to approach this question also. So this question is with the topic, belongs to the topic of the monotonic stack. Okay, monotonic stack. So we have to use prefix again here. Okay, so now let's see now in the prefixes what we will be storing here. What we will be storing is the sum. Okay, the sum. Okay, the prefixes are storing here the find the rectangle in the prefix right and the prefix left. So the prefix right and the prefix left are storing the indexes, that how much that on which index it is last, that that which index is having the height greater than or equal to it. Okay, let's see this, that which index is having the height greater than or equal to it. Okay, so the prefix left and prefix right, what they are storing, let's see that. Okay, it's a quite long question. Prefix left and prefix right. Okay, now prefix left is storing that which left index is storing the height greater than or equal to that current index. Okay, just like the 3 is storing the height 3. Okay, the ith index, this index is storing the height as a 3, but the left index, okay, the prefix left means the index which is left to it, none of the index is storing height greater than or equal to 3, only this index is storing that. Okay, so the 0, okay, I will give them indexes. Okay, 0 1 2 3 and 4, 3 and 4. Okay, so these are the indexes, and we have to know that whichever the index is storing the height which is greater than equal to that particular index. Okay, now one height, okay, this index is storing the height as a 1, but in the prefix of left it is also storing the 3, so that's why the 0th index is also having the height which is greater than that, this index, this particular index. Okay, so that's why we will store the prefix left as a 0 here. Okay, now after this we have 3 here. Okay, we have 3 here, so we have to get that 1 should be also be greater than or equal to 3, but 1 is less than 3, so that's why we cannot store here 0, we will store here 2. Okay, then after that 2 is there, now 3 is also greater than 2, so that's why we will store the 2 index here. Okay, after that 2 is there, so 3 is also greater than, and 2 is also greater than or equal to 2, so that's why we will store here 2. Okay, so in this way we will calculate the prefix of left, and then prefix of right. To calculate the prefix of right, 2 is having nothing more greater than that, so that's why 4 only. After that 2 is also having nothing. Okay, so yes, 4 is also, okay, the element which is present on the 4 index number 4 is also greater than or equal to 2. Okay, so then 3 is greater than 2 and 2, so that's why 2 is only there, present there. Okay, that particular index is only greater than or equal to that particular index. Okay, then after that 1 is there, but for 1 all that 4th index is also greater than or equal to that. Okay, so that's why. Okay, after this we have 3, but the 1 cannot be greater than the 3, so that's why we will store it here 0 only. Okay, now we have the prefix left and prefix right. Okay, so we can calculate that for particular index ith. Okay, so let's see for particular index ith index. Okay, for particular ith index, how many left and how many right are greater than or equal to that particular height. Okay, so let's see, its height is 3. Now its height is 3, so how many indexes are at the left are greater than or equal to that particular index, and how many indexes at the right are greater than equal to that particular index. Okay, so how many indexes are there? 0 and 0, so that's why the difference between them, 0 minus of 0 plus 1 is equal to 1. So this will be the, okay, so this type of the rectangle we will get. Okay, so in this case we have only the 1 as a length, and our height will be containing 3 blocks, so this will be the 3 by 1 case. Okay, 3 by 1 case, so that's why our we will get the rectangle of 3. Okay, area of rectangle with the area of 3. Okay, now after this we will try it for this index. Okay, so the index number 1, so here we have, okay, 0 and 4 up till the 4. Okay, so we will get to know that how many what is the length of that particular, okay, particular blocks, the number of blocks, the length of number of blocks which are having the minimum height as a 1. So the 4 minus of 0 plus 1 will be the 5. So 5 into 1 means 5 will be the breadth, 5 will be the breadth, and it can be the height. Okay, height of that particular that we can say as a length and breadth also. Okay, length and breadth also we can say. Okay, of the rectangle. Okay, so here we will get the 5. Okay, here we will get 5. Then after this we will get to know for this particular that particular second index. Okay, so here 2 minus of 2 plus of 1, so here we will get only 1. Okay, so 1 by 3 is the height, and this will be the length, or we can say as a breadth. Okay, so here we will get only 3. After we will traverse to index number 4. Okay, sorry, index number 3. Then in this we will get to know 4 minus of 2 plus of 1, so here we will get 3. So 3 into 2, 3 is the height and this is the length. Okay, sorry, this is the height and this is the length, so that's why we will get the 6. So in this whole matrix we will get the 6 as the answer, because it is the largest area of the rectangle we will get from this. So this prefixes, we have to make the function of this, and we have to apply this function for every of the row. Okay, so we will traverse firstly. So our logic, the final logic is, we will traverse at each row, and at each row we will apply this function. In this function we will apply this all the methodologies which is having the okay, so initially we will make the prefix of all the columns. Okay, and after applying the prefix of all the columns, we will traverse on each of the row of the matrix, and by traveling on each of the row we will pass on the prefix of that particular row to the function to find the rectangle, find the continuous rectangle which is having the largest area. Okay, and in that function to finding out the rectangle, so we will apply the prefix left and prefix right rule, and after that we will calculate the area. Okay, so this is our whole logic. Let's see the code, how we have applied this logic into our code. Okay, so here the maximum rectangle function is given to us. Then we have declared the dp as an array, so we can make it as a prefix also. Okay, then if it is a 1, so we are adding it. Okay, adding the previous value means basically we are doing the prefix. Okay, basically we are doing prefix. Okay, then we have, after applying the prefix, we have made the find rectangle function, and we are passing the dp of I value means the rows of the prefix of that particular row. So for every row we are applying this find rectangle function, and we are when we get to know the answer, so we are storing it into our answer of max of temp and answer. Temp means we are storing this find rectangle, the maximum rectangle which we are getting from that particular row. Okay, so how we will finding out the rectangle from that particular row? So we have the heights of that particular row, and after that we have the prefix. Okay, now we have to apply the prefix right and prefix left for that particular row. So how we will apply the prefixes? So we will use the monotonic stack approach. Okay, in the monotonic stack, when we have the st.empty means until we have the empty array, empty stack, so we will add the index at that stack. Okay, and if we have the number which is the number, okay, if we have the heights of that st.top means the number which is the index which is present on the top of the stack, if it is greater than or equal to the heights of I, okay, means which is currently present there. Okay, so we can pop out that one, because the current height, it is less than that particular one. Okay, so that's why. And after that, prefix of right of I will be equal to that st.top only. Okay, means the highest number, the highest index which is less than or equal to which is greater than or equal to that particular index ith height, so it will be the prefix right, and this same approach will be taken in the prefix left also. Okay, in this way we will get to know that how many number of right histograms or right columns are greater than or equal to that particular ith height. Okay, so we will get to know the left and right, and we can figure it out that how many what is the length of that particular number of ones. Okay, how many length of that row is having the height which is greater than or equal to that current row or current column. Okay, and in this way we will get to know the heights of I into prefix of right minus of prefix of left minus of 1. So in this way we will get this as a length, this as a height. Okay, so height into length we will get the as a area, and we will return this area in this function. And in this function, after returning it, it will be storing it as a temp, and we will update the answer as a maximum. Okay, this is our whole solution. Now my suggestion is that you have to first approach this question 84, the largest rectangle in the histogram, and after that go to try the 85th question. Okay, and if you are having any of the doubts, please comment down below, and I will be surely clearing your doubts. And thank you.